Prince George's County Public Schools presents HSA Prep for Algebra and Data Analysis. All problems will come from the public release problem sets, which are accessible to students through the Maryland State website at www.mdk12.org. Once again, that's www.mdk12.org. HSA Prep, because now it counts.
Hey everybody, this is Mr. Owens here with your HSA Prep lesson for today. We're going to work on a few problems dealing with Goal 1. So let's take a look at what Goal 1 actually states. Core Learning Goal number 1 deals with functions in algebra. The student will demonstrate the ability to investigate, interpret, and communicate solutions to mathematical and real-world problems using patterns, functions, and algebra. So a lot of these things that we're going to deal with in Goal 1 are probably some things that you've seen so far in your Algebra 1 course. Okay? So let's take a look at our first problem for today. That would be indicator 1, 2, 3. Student will solve and describe numbers using symbols and or graphs if and where two straight lines intersect. So when we talk about this section, we're dealing with what we call systems of equations. And a system of equations is just two or more equations that we're trying to solve. So let's take a look at our first problem. Our first problem says, look at the system of equations below. We have 12x minus 4y equals 8, and we have 3x minus y equals 2. The question says, which of these statements describes the graph of this system of equations? Now, it's asked, are they the same line? Are they two parallel lines? Do we have two lines that intersect only at 1, 1? Or are there two lines that intersect only at 0, negative 2? Now, in order for us to figure out what's going on with the two lines, the first thing we're going to have to do is we're going to have to change the format of the lines, okay? Now remember in the earlier problem we talked about slope-intercept form, right? So now we're going to convert both of our equations into slope-intercept form. Right now they're in standard form. And the reason we're going to do that is because we can learn a lot of information from the slope and the y-intercept of an equation, okay? So let's take a look. So we have our first equation. We have 12x minus 4y equals 8. Okay? And remember, our goal is to convert this into slope-intercept form. Right now, both of these are in what we like to call standard form. And remember, standard form is ax plus by equals c. Okay? Now we want to go to slope-intercept form, and let's remember what slope-intercept form. We talked about that earlier. Remember slope-intercept form is y equals mx plus b. So y equals mx plus b. So if we're converting from standard form to slope-intercept form, our goal is going to be to get our y by itself. So how would we do that? So we're going to get rid of the y by itself by first, we're going to subtract 12x to both sides. So let's do that. Okay. Now we have 12x minus 12, and here that cancels. So we have minus 4y equals negative 12x plus 8. Now I know, you might be thinking, why, Mr. Owens, why is that negative 12x plus 8? I'm going to tell you why. Let's go back and take a look at the problem. Here, remember, we have this thing called combining like terms. I know, I might have been thinking it a little bit myself. We have an 8 minus a 12, so why doesn't that give me a negative 4? Well, the reason is because both of these do not have the same variable. Here, this one has, the 12 has an x, but the 8 doesn't. So remember, you have to think about that. Keep in mind the whole concept of combining like terms, okay? Let's go back to the problem. So now to get y by itself, we're going to divide both sides by negative 4. So we're going to divide everything on this side by negative 4. Okay? All right. So now our minus 4s, they're going to cancel out. Whoop. So now we have y equals a negative 4 divided by negative 4 goes into negative 12, positive 3 times. And negative 4 goes into 8, minus 2 times. So the first equation in slope-intercept form is going to be y equals 3x minus 2. Okay? Now let's see if we can do the same thing to our second equation. Our second equation is 3x minus y equals 2. And remember, our goal is to go from standard form to slope-intercept form. So we're going to try to get the y by itself. We're going to do that by first subtracting 3x from both sides. So we're going to subtract 3x from both sides of the equation. What happens here? Cancels. So now we have a negative y equals negative 3x plus 2. Remember, we're not going to combine these two and make that a negative 1x because they're not like terms. Now, we have a negative y equals negative 3x plus 2. Are we done? I thought you would say no. No, we're not done because we haven't solved for y yet. We still have that negative over there. So the question is, how do we get rid of that negative? Well, let me tell you. We get rid of the negative by dividing both sides by a negative 1. So let's do that. Now, the reason we're dividing both sides by a negative 1 is because in front of this y, there's like, it's not written there, but there's like an imaginary negative 1. He only comes out around HSA time. So now we want to divide both sides by negative 1. So the negative 1's here are going to cancel. So y equals negative 1 goes into negative 3, positive 3 times. And then negative 1 goes into 2, minus 2 times. Now, what do we notice? Our two equations are the same. So that would correspond to answer choice A. These lines are the exact same line. Okay? So a key to that problem is you want to make sure that you're able to convert the equation from standard form into slope-intercept form. And from that point, you can kind of tell whether or not the equations are the same. Okay? Now the reason well, of course, they're the same because they have the same slope and they have the exact same y-intercept. So if you see the two equations are exactly the same, that's why we had answer choice number A. Okay? Now, we have one more question in this set, and we're going to do that now. So let's take a look at our last question, dealing with systems of equations. And it deals with Simon and some pizza. So let's take a look at our problem. For a party, Simon has pizza delivered to his home. Pizza House charges $8 per pizza plus an additional $12 for delivery. Spaghetti World charges $10 per pizza with no delivery charge. If Simon orders the same number of pizzas from each store, how many pizzas must be delivered for the total cost to be the same for Pizza House and Spaghetti World? Okay, so Simon has a situation here. He's trying to order some pizza. He's got a party going on. He's got a few friends over. He's trying to have this party. So he wants to figure out how's he going to get the same amount of pizza from Pizza House and Spaghetti World. So let's take a look and see if we can help Simon in his party. Okay, so the first thing we want to take a look at is we want to look at our question. So we're analyzing our problem. So the question says, if Simon orders the same number of pizzas from each store, how many pizzas must be delivered for the cost to be the same for Pizza House and Spaghetti World? Okay? So we want to know how many pizzas have to be delivered for the total cost to be the same for Pizza House and Spaghetti World. Okay, now let's try to define some variables here. So first of all, we want to use, let C is going to represent our cost. Okay? And P is going to represent the number of pizzas. I personally enjoy pepperoni, but you may have a different preference. So let's just say he orders some pepperoni pizzas. So now we want to set up some form of equation to model this situation. So it says Pizza House. So let's start with Pizza House. So Pizza House charges $8 per pizza. So $8 per pizza. So $8 per pizza. Remember, per in math means multiply. So $8 per pizza plus addition. So plus an additional $12 for delivery. So $8 per pizza plus the $12 delivery charge equals our cost for Pizza House. Okay? Now we have Spaghetti World. And not only is it Spaghetti World, but they also sell pizzas. So Spaghetti World, we have Spaghetti World charges $10 for pizza. So $10 for a pizza pie with no delivery charge. Now, you know, Spaghetti World sounds better already because they're not charging for delivery. So that would be equal to the cost at Spaghetti World. So Pizza House is 8p plus 12. That equals the cost. And Spaghetti World, we have 10p equals our cost because Spaghetti World doesn't charge for delivery, like I said. So right now, I want to go with Spaghetti House because they're not charging me. Spaghetti World because they're not charging for delivery. But let's see how many pizzas Simon would have to order. Okay, so now we want to solve what we call a system of equations. Now, there are two ways we can do this. So the first way I'm going to show you how to do it is how to do it algebraically by actually going through and solving an equation. The second way I'm going to show you how to do it, I'm going to show you how to do it using our calculator, and that's another skill that you can use to help you on the high school assessment, okay? So what we're going to do is we're going to solve a system by substitution. Okay, solve our system by substitution. So what that means is that we're going to replace one variable for another variable. So now we said that we're looking for the cost to be the same for Pizza House and Spaghetti World. So really we want the cost for Pizza House to be equal to the cost at Spaghetti World. Now we're going to replace our C values with the equations that we have up here. So our cost for Pizza House, remember we said, is 8p plus 12. And our cost for Spaghetti World is 10p. Because remember, Spaghetti World doesn't charge a delivery charge. Okay, now we're going to solve our equation. So in order to solve our equation, we're going to isolate our variable p. So in order to move our 8p over to the other side of the equation, we're going to perform the inverse operation and subtract 8p from both sides. Okay, so our 8p minus 8 minus 8p, that cancels. So we have 12 equals 10 minus, now 10p minus 8p is going to be 2p. Now in this case, we can say that because they both have the same variable, so we're combining our like terms. Now in order to get the p by itself, we're going to divide both sides by 2. We divide both sides by 2, so p equals 2 goes into 12 6 times. So that means that Simon would have to buy 6 pizzas from both Pizza House and Spaghetti World in order for his total cost to be the same. Now we explained how that works. Now let's justify and make sure we know why our answer is correct. So let's go back to our original equation. We have 8p plus 12 equals 10p. Okay? Now what we're going to do is we're going to substitute our value for p into our equation. So I'm going to leave a space for a second, and we're going to put our p value in. Okay. So we said p is equal to 6. Okay. So now we have 8 times 6 is 48 plus 12 equals 10 times 6, which is 60. 48 plus 12 is also 60. So remember, both sides are equal, so we know, check, we're right. So that means it's going to cost Simon $60 at Pizza House and at Spaghetti World. Now, let's take a look at the same problem this time, but now this time let's use our graphing calculator. So if we go to our calculator, the first thing we're going to do is first of all, we're going to turn it on because you can't use a calculator if it's not on. So first thing we're going to do is we're going to turn it on. Now it's on because you see the light blinking. So it's on. Now we're going to press our y equals key. And in y1, we're going to type in our equation for Pizza House. So we have 8x. So we're going to, instead of using p, we're going to use x, but it still represents the same thing. X represents, in this case, our number of pizzas. So 8x plus 12, that's our first equation. And then our equation for Spaghetti World, 10p, or in this case, we're going to use 10x. Okay? Next thing we're going to do, once we enter our two equations, now we're going to press graph. Okay, whew. Now, what we want to do is we want to press our trace key. Now, first of all, initially, you may not see this. So if you come up initially and you go to the standard window, you may not see the place where both of the graphs cross. So one of the things you may want to do is you want to press the zoom key and you want to go down to where it says 0 and press enter. That's what we call the zoom fit key. So it'll actually kind of make it a little bit easier for you to see both of the lines. So now if you notice, we're looking for the place where the graphs cross. And the graphs, if we press trace, the graphs cross somewhere up here. Okay? So we're going to kind of go up toward the top. So that's what we're looking for, because the point where the graphs intersect, that's going to be our solution to the equation. So what we're going to do is we're going to press second and trace, and we're going to go and press number 5. So we're going to go down to intersect and press enter. And we're going to go, so we did second, trace, we pressed the number 5, and now we're going to press enter 3 times. So 1, 2, and 3. And it tells us that our point of intersection is x equals 6 and y equals 60. So the 6, remember, the 6 represents the number of pizzas that Simon had to buy in order for the cost of both to be the same. And our 60 represents the total cost for pizza at Pizza House and Pizza World. Okay? So that was our little question on solving systems. Now, I hope you all enjoyed this session. I wish you all the best on your high school assessment. I want you all to strive for 412 and beyond. I'm Mr. Owens, and I'll see you later.